Hello everyone, in this video let's discuss about common base configuration. So if you are new to our channel, please subscribe for more engineering related topics. Let's consider PNP transistor. So let's consider PNP transistor. What is PNP transistor? So the transistor made up of combining two p type of semiconductors and one type of semiconductor, that is PNP. P type of semiconductor, N type of semiconductor and P type of semiconductor. So this type of semiconductors transistor will be called as PNP transistor. Every transistor will be having three terminals, that are base, emitter and collector. The transistors can be connected in circuit by using three ways. That is, first one is common base configuration, second one will be common emitter and third one will be common collector. Now we are discussing about the common base. What is common base means? If I consider this resistance R because of the emitter and this resistance R because of collector, so RC and RE, then in between the emitter and the collector the base will be common. So the current IB will be common, that is base current. So the base is common between emitter and collector, so it will be called as common base configuration. So VEE, what is VEE? Emitter. So emitter voltage. Next here VCC. What is VCC? VCC is the voltage across the collector configuration. Next, here comes the current IE. What is IE? IE is the current because of the emitter, and here IC. What is IC? IC is the current because of collector. Next, the IB. So we would want represent the voltage of the base configuration because it will be grounded, therefore its value will be equal to 0. We will represent the direction of the current IB, that is the base current IB. Now to make this common base configuration working, we must bias the transistors. So we must bias the transistor, that is PNP transistor. How means? We will forward bias the emitter and the base junction. So we will forward bias the emitter and base junction, and we will reverse bias the base and collector junction, that is collector and base junction will be reverse biased. So in this condition what will happen? Now we must find out the current amplification factor for every configuration. For common base configuration, what will be the current amplification factor? It is the DC current amplification factor. So I represented DC right here. Alpha will be the current amplification factor for common base configuration. So what is the value of it? Output current divided by input current. Output current divided by input current. So therefore the input current, that is in the left hand side, it will be the input side. So the input current is IE, and the output current, that is right hand side, in right hand side the current is IC. So IC will be the output current. The current amplification factor alpha is equal to IC divided by IE. Now we must represent the input characteristics, that is I versus V characteristics graph for input and output. Now let us consider for the input characteristics of I versus V. What is I versus V? Current versus voltage. So now to plot the input characteristics graph, so we must consider the left hand side as it is the input part for the common base configuration. So what is the voltage right here? The voltage is VBE. What is VBE? VBE is the voltage at the emitter base junction, and VCB. What is VCB or VBC? VCB is the voltage across the base and collector junction. Now To plot the input characteristics, we must need the value of input current, input voltage and output voltage. We need the values of input current, input voltage and output voltage. So what is the input current? That is left hand side we must see. What is the input current? That is IE. Next, what is the input voltage? VBE. Next, what is the output voltage? So output voltage means right hand side. What is output voltage? VCB. So now we must keep the output voltage as constant. As we are plotting the graph for input characteristics, we will keep the voltage, that is output voltage, as constant, VCB. Now we are plotting I versus V characteristics, that is IE, input current IE versus VBE. VBE is the input voltage. Up to some point, there will be slow growth in the current. When the current will extend or cross the threshold voltage, it will spark constantly. So therefore, if we keep the value as VCB is the constant value, no? So let VCB is equal to 5 volt. If VCB is equal to 5 volt, up to the threshold voltage it will rise slowly. After the threshold voltage, it will sharpen the current. So the current will rapidly increase. So for 5 volt. Now let's change the constant voltage VCB value. Let VCB is equal to 10 volt. When VCB will be equal to 10 volt, up to certain voltage, that is up to threshold voltage, the same process will take place, and as the threshold voltage is crossed, the current will sharply increase. Now this is the VCB value, which is equal to 10 volt. Now we are getting the concept that as the voltage value increases, that is as the constant output voltage value increases, the graph is shifting towards the left. Shifting towards the left side. So this you must write. Now let's plot the output characteristic graph for the common base configuration. For output characteristic configuration, output characteristics, that is also between I versus V. So here in input characteristics we took input current. Now we must take output current, output voltage and input current. So what we took in the input characteristics table, input current, input voltage, and we made the voltage as constant. Here in the output characteristics, we will take output current, output voltage and input current. And we will take input current and make the input current as constant, because we are plotting the graph for output characteristics. So what is the output current? Output current means right hand side. What is there? IC. Next, what is the output voltage? VCB. Next, input current. So input current means left side. What is the input current? IE. So I must keep the IE value as constant, as it is the input current. To plot the output characteristics graph, we must keep the input current constant. So now let us consider the input current constant now. So IE value is equal to 10 microampere. 10 microampere. Next, another level will be IE will be constant, whose value will be equal to 20 milliampere. So okay, now let's plot what is IC. So the output current is IC and the output voltage is VCB. The VCB will produce a small amount of current, which produces the small amount of current which is produced by VCB. So which is ICB. The current produced because of VCB, which will be very small, almost negligible, we won't consider, but you must plot in this graph. Next, when the current IE is constant, that is 10 microampere, as the voltage will increase, it is produced, the current will produce, but it will be slightly less than 10 microampere. That is, it will be slightly less than the constant value that we have kept. And same for the 20 microampere also, little less than that. So when we increase the value of VCB, that is voltage in the negative side means this side, no, negative minus axis, the current will drop sharply. The current will drop sharply to 0. This area where the current sharply drop to 0 will be called as the saturation region. And the region where the current is constant or the current is not equal to 0, so this area we will call as active region. And where there is no current, so we will call it as cutoff region. So if they ask in the exam, so write this theory, then this formula and input and output characteristic graph with this circuit diagram. So hope you understood the concept. If you have any doubt, please comment below. If you like the video, please subscribe for more engineering related topics. Thank you.